Welcome to Brain Vision.
So we know the ball rolls without slipping, so the angular velocity is equaling the linear speed divided by r, the radius of the ball. And so we can say that the energy at A equals the energy at B and simply use conservation of energy. We can say that the gravitational potential energy at A equals the potential energy at B plus the final potential energy at B. This would be equaling the potential energy at B plus the kinetic energy of the center of mass at B plus the rotational kinetic energy of B at point B. And so we can say mg r equaling mgr. So we're actually accounting for the gravitational potential energy of the ball even at point B. And this will be plus 1/2 times mass sub v b, mass times the velocity of b squared. So that would be the translational kinetic energy, and then plus the rotational kinetic energy, 1/2 times the moment of inertia times the angular velocity at b squared. And so we can then say mg r equals mg r plus 1/2 mv sub b squared plus 1/2 times the moment of inertia of a sphere, 2/5 m r squared. And then this would be multiplied by the linear velocity at b divided by the radius of the sphere squared. And so the velocity, the linear velocity at b, is going to be equaling 10/7 times g multiplied by r minus r. This would be our linear speed at b. Again, the square root of 10/7 times the acceleration due to gravity times the radius of this curve minus the radius of the sphere itself. That is the end of the solution. Thank you for